Hi. I'm Agnibdu Sinha, and this is my video submission for the second assignment of CS441. I'll just go through the project and what it does, and the code in short. So the project is basically we have to design a large language model decoder. In the previous assignment, we had trained the embeddings uh, for the tokens basically. And we are using the same embeddings to now create a neural network that predicts a new token for a list of tokens given the embeddings which we had created in the previous assignment. So, as I said, we have in the previous assignment we had trained the embeddings for tokens, and in this project we are using a trained embeddings for predicting tokens in a sliding window context. So, first of all, okay, I'll just go through the process a bit later on. The first thing I have to notice, we are handling parallel distribution via Spark and AWS EMR. Now, what exactly is the sliding window tokens? We are generating a list of tokens. Say the window size is 4, and for each of the 4 strings, token will be predicted using the embeddings of the tokens in the sliding window vector and the embeddings of the output basically. The model is basically three-layer neural network, and the input vectors consists of the embeddings of the first part of the sliding window, and as I said, the output vector is just the embeddings of the token that is basically the output of the sliding window, which follows the sliding window. So I'll just go through my code quickly. Okay. This is the LLM trainer class. This is the main class of this project. Basically, it handles both creation of sliding windows as well as training the model. So if you can see, I'll just go through this shortly. This part, the load embeddings part. The input tokens dot load token embeddings path is basically where the project takes the token embeddings from a text file. The text file has all the token embeddings that we had created in the previous assignment. And if you can see the train model function, this is basically for training the model. So, and after we are in this part where we are training the model, after if it is successful, case success, we are outputting the metrics first of all into a file, and of course the trained model into a zip file. So two outputs. So there are three read-write operations. One is reading the embeddings, token embeddings, outputting the metrics, outputting the model, and we are using HDFS for all of this, as I'll show you in a while. I'll just go over the Spark Neural Trainer class. This is my Neural Trainer class. This is basically where the training takes place. I'll just show you this is my model architecture. There are 3 layers. I'm using the ReLU function for the first 2 layers and identity function for the final output layer. And if you see here, yeah, when we are starting the training, while training, I'm also taking a bunch of metrics, like see if you can see here, the batch metrics is one of them. Then there are epoch metrics, then final metrics, Actually, let's just go over the metrics quickly. This is the training metrics collector. And if you can see here, these are the kind of metrics I'm taking. There's a gradient stats, batch metrics, epoch metrics, Spark executor metrics, training metrics, Spark training metrics, model metrics, and data distribution stats. We are taking all of the metrics during training, and yeah, we are outputting them into a file as I'll show you later. So, and I'll just shortly go over the sliding window part of the project, which is technically the first part. Here, there are create embeddings. Um, Create embeddings definition of the function, which I had shown in the LLM trainer class. Here's the compute positional embeddings, which is a required step for training the model. And combined embeddings is basically where I'm adding the positional embeddings to the already trained embeddings that we had in the first assignment. It's just position-wise embedding dot add positional embeddings. And of course, yeah, we are passing this and we are handling this entire data via sliding windows. And needless to say, we are using RTD datasets throughout the project because of Spark. Yeah, that's it for the code. And quickly, the last thing, I'll just go with the application.config file. Here you can see the output directories are mentioned, which is HDFS model output and HDFS metrics output for saving the model and the metrics. And the embeddings path is also given in HDFS. So I'll just quickly go to AWS EMR. Now, this is a EMR cluster I already created, and I had run two steps just for testing purposes previously, prior to making this video. And I'll go. This is I've SSH'd into the EMR cluster because we are using HDFS for all read-write operations here. As you can see, there's only the embeddings file, and the embeddings file basically I'll just ls into the embeddings file, embeddings folder, sorry. Yeah, the embeddings folder contains the embeddings.txt file, which is the input for our project. Now I'm going to add a step to this Spark application. Trainer. I'll take the jar file in my S3 bucket. This is my jar file. For the Spark submit options, three Spark submit options, the class, executor memory, and driver memory. I'm going to add this step. Now I'll let this train for a bit and I'll come back once this step has finished. Hi. So the step has been completed, as you can see here. And just a sec. Yeah, sorry about that. I think there was some issue with my video recording. Yeah. So as you can see, the step has been completed here. So I'll just quickly move over to the EMR cluster and I'll just HDFS ls into this. Yeah, so these two folders got created in the process of like running the step. I'll just quickly ls into this and I'll show you what this contains. This contains a text file and model output. This contains a zip file of the model that has been trained. Now I've already downloaded the text file, so it is easier for me to show you. I'll just quickly move over to there. This is the text file that contains the various metrics and whatnot that has been like during the training during the running of the project. So yeah, so the training summary is here, the loss, validation accuracy, training accuracy. Epochs are 10 and total parameters and layer sizes, the as I said, like the three sizes. Um, Executor memory, storage, memory used. So that is one part. And the detailed epoch details are provided here. The loss accuracy, validation loss, validation accuracy, and the learning rate. So if you can see, as the epoch goes by, the loss decreases. It's 0.4, 0.27, 0.22, and finally in the 10th epoch, we have 0.09, which is, I think, a fairly good loss. And of course, validation loss also decreases as time goes by. If you can see here, it starts at 0.42 and it ends up at 0.18. But if you can see, Epoch 9 has the best validation score. It's 0.15. So that means Epoch 10 must have, it probably has gone through overfitting. Anyway, these are all the metrics that has been taken during the training of the project. And yeah, that's that's my uh, that's my final output for this. Just a sec. Yeah. So this is my project, and this is my video submission for the assignment too. Hope you enjoyed it. Thank you.